Hello everyone, we are invisCaptcha. We are making a CAPTCHA model which acts passively in the background to detect whether the user is a bot or a human. And this project was floated in the Smart India Hackathon under the Ministry of Electronics and Information Technology. We are team ID 46424. Proceeding ahead, I'll just enter my Aadhaar number here and let's enter the OTP. Now, this is our approach. Now, what happens in the active captcha? Are you tired of proving to every website that you are not a robot? We are here to help you out with this. Now, in active captcha or in the traditional captcha based methods, they require the user to actively engage with the captcha and solve some trivial puzzles or do some math calculations or identify some objects in the image which are not easily identifiable by the bot. To resolve this issue of actively engaging, we introduce a passive plus plus solution, which is a two-check process. In the primary check, we have honeypot trap method, which employ a honeypot deployed at the backend of the website, which detect a bot and traps it. Now, coming to the HTTP methods, we employ a neural network and a discrete time Markov chains, which finally output a score whether the user is a bot or a human. Coming to the secondary check, we have the data of mouse and keyboard logs of the user, what activity the user is doing on the website, what letters he is typing on the website, and based on this, we can send this to a LSTM model which is deployed at the backend. And this LSTM model, which will give a probability score, which when we threshold it against our score, we can safely say that this was a bot or this was a human. And if we are in some sort of confusion, we can prompt the user to engage with the active captcha based methods and prove that he is a user, he's a human. Now, coming to the technical aspects of these things, first of all, let's begin with the primary level, which are the HTTP methods. For the HTTP methods, we send the HTTP request to a machine learning model, which is most probably a neural network in our case. And this neural network then outputs a probability, which is the probability whether the user which is interacting is a bot or a human. Now, this probability is then sent to a SPRT module, which finally outputs a classification, a binary classification, which is 1 if it is a bot or 0 if it was a human. Next, in the secondary level checks, which primarily rely on the behavioral characteristics, we have mouse movements and keyboard logs. Now, these behavioral characteristics are then fed to a LSTM model, which run and do some computations and then output whether the user is a bot or a human. Next, we have honeypot traps. These run in parallel to the aforementioned checks. Now, for honeypot traps, we have three levels of traps. For the layer 1 traps or the surface traps, these are just plain form fields which are hidden from the GUI. And since it is hidden from the GUI, it means it is not visible to the normal user. And it is only visible to the bot, which passes to the JavaScript pages or the HTML pages. And the bot will engage with the form, and we can thereby detect that, okay, it is a bot and not a human. For the layer 2 traps, which is the behavioral traps, we rely on fake AJAX calls that simulate dynamic content updates. Now, this can prove to be useful in our case because humans are impatient and they will tend to click away immediately, but the bot will wait till it gets a response. Thereby, we can flag that yes, it is a bot. Now, coming to the level 3, which is the logical traps, we can put some decoy API endpoints which look realistic but are not actually realistic. And if the bot tries to interact with them, it gets stuck. Now, going next, coming to the feasibility and viability of the solution. Every step of this idea is achievable because this model requires no human interaction to train. And apart from this, uh, everything from the honeypots and the machine learning models can be plugged into the JavaScript framework and can be deployed on the website easily and can be rendered on any browser. This makes the idea very cost effective and it also makes the approach very much feasible. But we encounter several challenges. Now, some of these are A super intelligent bot may be able to evade the honeypot traps, and this can make it difficult to detect. Apart from this, the to and fro transfer of the user logs may require some additional bandwidth and higher transfer rates. The computational overhead, which may occur due to the LSTM model doing some computations, may consume some additional RAM. And the potential false negatives, which is when we classify the user as a bot, when we classify a real human as a bot wrongly, may prompt the user to reload the page or resort to traditional captcha methods. The potential solution to these challenges can be we can employ a dynamic honeypot trap method, which places the traps dynamically and is not static and loaded at once. This can help detect some very intelligent bots. Apart from this, we can try to do some feature reduction or dimensionality reduction of the features of the user logs so that we can reduce the size of the logs and thus requiring lesser bandwidth to transfer. Apart from this, we can use light gradient boosting methods in place of as an alternative to LLMs, as an alternative to LSTMs because they have shown better results in accuracy and also they took lesser time in computation. Coming to the benefits and impact of this, the benefits are this enables seamless user verification without interrupting the natural flow of interaction with UIDI portals. The analysis of multiple behavioral factors can make the system more and more accurate and efficient. The behavioral data-driven analytics may provide valuable user interaction data to improve UIDAI's digital services. Scalable protection, which can safeguard multiple UIDI portals and APIs with a centralized backend ML infrastructure. Coming to the impacts of this, this can help the visually challenged people to interact more with these websites without having to engage actively. Over the time, the user experience will get seamless and better and better. With increase in Gen AI powered bots, the traditional CAPTCHA based methods are getting redundant. Our model places a check on these Gen AI bots. Apart from this, our architecture will have a tangible impact on the lives of common people when large scale integration of invisCaptcha is done across various government domains. This will increase accessibility of various digital services provided by the government, especially catering to the underprivileged. Now, coming to the research and references, these are the references we used to get inspiration from. Uh, Let me go through them one by one. We used web bot detection using mouse movement, which was published in 2023. We used efficient on-the-fly web bot detection 2021. We used a mouse dynamics data set. And apart from this, we also used these two GitHub repositories and Honeypot's Prisoner for honeypot trap detection. Thank you.